Welcome to this video on the standardized normal distribution and the RGuroo normal calculator. Let's begin. After watching this video, you will be able to demonstrate how the normal calculator can be used with z-scores, and use the normal calculator in RGuroo to find the probability of an event using both standard and between settings. So let's compare the normal distribution to the standardized normal distribution. With a normal distribution, notice that it's centered around the mean, which is represented with the Greek letter mu. The tick marks represent standard deviation, the population standard deviation sigma. And the x-axis units are the population variable units. Conversely, the standardized normal distribution is centered around 0. So instead of being centered around the population mean, it's centered around 0. And the tick marks are counting the number of standard deviations, right? And remember, this is your z-score, so that the tick marks are 1. So again, it's centered around 0, and you have tick marks of 1. Over here, it's centered around mu, and the tick marks are sigma. So in this case, with the standardized normal distribution, your x-axis is the z-score, which is a unitless measure, whereas when we are actually graphing just a regular old normal distribution, we do have units on the x-axis. So we will learn how to use the normal calculator in RGuroo to do the following things. Calculate the area to the left of a given z-score, to the right of a given z-score, between two z-scores, and calculate the area to the left of a z-score and the right of a different z-score. Introducing the normal calculator in RGuroo. Previously, we have used the empirical rule to find the area under the normal curve. This is a very limited approach, however, as it relies on values being a whole number of standard deviations from the mean. A more robust and less computationally intensive approach is to use a normal calculator such as the one in RGuroo. Let's open RGuroo and learn how to use the normal calculator. Once you've logged into RGuroo, you'll notice this accordion menu over here. Select Probability Simulation, and then come down to this box and click on Probability. The first option says Probability Calculator, and your two options are Continuous and Discrete. So we're going to select Continuous because the normal calculator is a continuous probability distribution. Then, if you look in here, it says Distribution Normal, and there is a drop-down menu. There are many different types of continuous distributions, but luckily for us, the normal distribution is the default setting, so we don't even really have to click on this right now. Okay. Also lucky for us, the standardized normal distribution is also the default setting, so the mean is already set to 0, and the standard deviation is already set to 1. So now we have to think about, well, what inequality do we want? Do we want below, above, between, or outside? And we don't know yet, right? So we're just going to leave that blank for now. But this is how you access the normal distribution calculator in RGuroo. And in case you forget, or if you want to jot it down, this is what we did. We logged into RGuroo.com. We went to Probability Simulation, Probability Calculator, and then Continuous. Standardized normal distribution example 1, area to the left of a z-score. Determine the area under the standard normal curve that lies to the left of the following z-scores. Round all answers to 2 decimal places. So notice we have 1, 2, 3 examples. So let's go ahead and go back to RGuroo and start practicing. So the first one, letter A, says z is equal to 0.45, and we want to find the area to the left of this value. So the first thing I'm going to do is I'm going to go to this box right here, and I'm going to type in 0.45. Okay, I want the area under the curve to the left, so I'm going to select below. So if I just hit the I icon, I get a value here. But I strongly encourage you to click this graph button, because just having words and numbers, sometimes it's hard to visualize what we're looking at. So let's click this graph box and then look at it again. So notice when we do this, now I have a nice visual image of what we're looking at. So looking at this graph, did I successfully find the area to the left of this z-score? Well, I did, right? That's exactly what I asked it for, and that's what it gave me. So the area to the left of the z-score is about 0.6736. Okay, and the beauty of this z-score is, or sorry, of using the graph is that, let's say, I don't know, I was in a rush or stressed out or whatever, right? And I had accidentally selected the wrong word from this drop-down menu. Then I can come down here and it's very clear, oh gosh, you know what? I wanted the area to the left of this value, but I accidentally picked the area to the right. So that's why I always like to see the graph. I always like to check myself because I know that unfortunately I'm human and I do make mistakes sometimes. So again, you want below 0.45 and we click again on the icon and we have this probability right here. And this is the graphical image that accompanies what we tried to find. So for our first example, the area to the left of z equals 0.45 is about 0.67 or 67%. So let's do the next one. This one, again, it's the same thing. We're still doing to the left of this z-score, but we have a different z-score now. We have z equals 1.23. So if I go back to this basics button, all I have to do is type in 1.23. I just have to change the value there. And again, I hit the little I. And so you can see the probability right here is 0.8907. So that's going to be my answer. And again, I just like to look at the graph. It comforts me to know that I am shading the desired portion. I am shading to the left of the z-score. So for letter B, we would say that the area to the left of z equals 1.23 is about 0.89 or 89%. So let's do this last one here. This time we have a negative z-score, which is interesting. So we want to find the area to the left of z equals negative 1.25. So again, I hit the basics button to get the menu back, and I want below negative 1.25. So I type that in, press the I. Okay, and you can see the probability is given to me up here. And again, if I scroll down, you can see that the area is to the left of this. Another point of or value in using the graph is, what if I had accidentally forgotten the negative sign, right? So for example, again, let's just say I was in a hurry or rush or I was distracted and I accidentally typed in positive 1.25, right? That's it's gonna be very obvious when I do the graph here. So then I'm like, uh-oh, wait a minute, I wanted a negative score and I typed in a positive z-score by accident. So then I go back here and again, I can see the probability is about 10%. And again, if I scroll down here, I can see that the z-score is it is negative, right? It's to the left of the 0, which is what I wanted. So again, the area to the left of z equals negative 1.25 is about 0.11 or about 11%. So now we're going to do almost the same thing. This time we're just going to find the area to the right of some z-scores. And I wasn't very creative here, so we're going to use the exact same z-scores, the same 3 z-scores. Now we just want the area to the right. So let's start with the first z-score. Remember, it was z equals 0.45. So again, we click on the basics button to get our menu back. I'm going to, I think the first thing I want to do is I want to change this drop-down menu, because I think if I type in 0.45 and then I change the value or change this word here, then that field disappears. So make sure you change this first so you don't have to type it in twice. So I selected above because again, I want the area to the right of that z-score. So I'm going to type in 0.45 and the graph is still selected. So let's look at it. Okay, so here's my probability. It's about 0.3264. Okay, and again, I like the graphical imagery of it all because it shows me I did shade to the right of the z-score, which is what I meant to do. So in this first example, the area to the right of z equals 0.45 is about 0.33 or about 33%. So let's do the next two. Now we have z equals 1.23. So again, I go back to the basics menu, I type in 1.23, that's the only thing that needs to be changed here, and I hit the I. Okay, so here is the area, it's 0.1093, and again, the graph shows me I did in fact shade the desired region. I shaded to the right, which is what I meant to do. So we would say that the area to the right of z equals 1.23 is about 0.11 or about 11%. And last but not least, we want to shade to the right of z equals negative 1.25. So again, we click on Basics to get back to our menu. We type in negative 1.25 and we hit the eyeball. Okay, here's my area right here, 0.8944. And again, if I look at my picture, I did in fact correctly type in a negative z-score, negative 1.25, and I did shade to the right. So the area to the right of z equals negative 1.25 is about 0.89 or about 89%. Now, you might think that I was just being lazy when I used the same z-score in both examples, but this is actually a really nice opportunity for us to demonstrate the fact that the area total complete area under the curve is 100%. So in other words, let's say I take any z-score here. So let's say I take z equals 0.45. So if I add together the area to the left of this z-score and the area to the right of this z-score, right? So we have about 67% and about 33%. Well, they add to 1 or 100%, which is exactly what they should, because remember, the total area under the curve is 1 or 100%. Same thing with the next one, right? If I take the area to the left of z equals 1.23 and the area to the right of z equals 1.23, I have 89% plus 11%. Again, that adds up to 100%. Same with the last one. If I take the area to the left of the z-score and the area to the right, that's all of the area under the curve. So again, the probability sum to 1 or 100%. Let's move on to example 3, where we will find the area between two z-scores that is symmetric. So suppose we are asked to find the area under the standard normal curve that lies between z equals negative and positive 1.5. So let's go over to RGuroo and see how we would do this. So in RGuroo, we already have this menu open, right? So the first thing I would need to do that I need to change is to click on this drop-down menu. So I want to go down to Between, and notice now I have not one but two boxes. So I want to find the area between negative 1.5 and positive 1.5. So let's see what happens when I do that. Okay, so now again I have this picture. This is exactly what I wanted, right? I want to find the area, the shaded area between z equals negative 1.5 and z equals positive 1.5. And as you can see here, it's about 87%. So let's do another example. This time I want to show you that we don't have to have a symmetric area. We can have two different z-scores. These are obviously still different. One is negative, one is positive, but they have the same absolute value, and that doesn't have to be the case. So let's look at example 4. This time we're asked to find the area under the curve between z equals negative 0.7 and z equals positive 1.59. So again, go back to RGuroo, pull up the menu. So this time, the only thing I have to change are the two z-scores. So I type in negative 0.7 and positive 1.59. Again, hit the little eyeball. Okay, and here is my picture right here, and here is my probability. So again, here is the image, and as you can see, the probability is about 0.7 or about 70%. So let's do the last type of problem. So this time we are going to find the area outside of two z-scores if those z-scores are symmetric. So we want to find the area outside of z equals negative 1.5 and positive 1.5. So let's go to RGuroo and see what that would look like. So again, we click on Basics to get our menu back. So as you can see, there are 4 options. We've played around with below, above, and between. The only one we haven't messed around with is outside. So let's mess around with that this time. So we're going to type in negative 1.5 and positive 1.5. Okay. And there we go. The picture is exactly what we wanted. We wanted to find the area in these two tails. Okay. So we can go back to our problem. And we would say that the probability is about 0.87 or about 87%. So the last example I want to do is also outside, but this time we can have asymmetric z-scores, meaning they don't have the same absolute value. So it says determine the area under the standard normal curve that lies outside of z equals negative 0.70 and z equals positive 1.59. So again, we go back to our menu, and we already have outside selected. So we're just changing these two z-scores, and we go ahead and hit view. And as you can see, there is asymmetry here, but that's okay. But the picture does represent exactly what we meant to capture: the area to the left of z equals negative 0.7, and then the area to the right of z equals 1.59. So as you can see, the probability is about 0.30, or about 30%. So, having watched this video, you should now be able to demonstrate how the normal calculator can be used with z-scores, and use the normal calculator in RGuroo to find the probability of an event using both standard and between settings.